All right, last but not least, and I don't really know why your author chose to put it in this section. I probably would have put it earlier in the chapter, but it doesn't really matter. We're going to talk about counting, since you guys can watch these things whenever and as often as you want to. It doesn't really matter. Let's just talk about the counting. Now, again, I hope that you've seen these things before, so I'm going to blast through these relatively quickly. However, that said, I will go through some examples and make sure that everybody's on the same page. So give me, I don't know, 10 minutes or so to get through this part. We've already talked about the fundamental principle of counting. That's where if I'm going to combine a bunch of things, if there are n ways to differentiate, again, if there are n ways to figure out the number of pants that you have, and there are m ways to figure out the number of shirts you have, and there are z ways to figure out the number of shoes that you have, then the number of distinctly different outfits is n times n as in Nancy times m as in Mike times z as in Zulu. All right, fun, etc., etc. All right, if we're mixing hats and gloves and all that other stuff, you've seen these things a million different times. If you haven't, tackle me and let me know, and we'll go over it real quick. Okay. Let's talk about this guy right here. Let's talk about n factorial. All right? N factorial, hopefully you've seen this, is n times n minus 1 times n minus 2. This is just the mathematical structure of it, times dot 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 times 2 times 1. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. Now that's just the mathematical way of doing it, but let's make sure we understand exactly what it means. What it really is it's the number of ways to organize, to order n things. Okay, so let's say that I want to, there are, I don't know, let's keep it simple. There are 5 people in my class, and I want to line them up against the wall. So I'm going to order them so that I can shoot them. I'm just kidding. I'm going to shoot you. I'd sneak up from you from behind. Anyway, so think about it this way. I'm going to use the fundamental theorem of counting to prove that there are actually 5. I've got 5 kids that I'm going to order. I'm going to show you that there are 5 factorial ways to do this. Think about it this way. I got 5 kids that I'm going to line up against the wall. How many choices do I have for the first kid? There's 5. How many kids do I have for the second choice? There's 4, etc. 3, 2, and 1. Because of the fundamental principle of counting, and because I'm making a set of kids lined up against the wall, this is 5 factorial. All right? That is the basis for probabilistic counting. It's going to get used over and over and over again. Okay? Now, what we're going to do next is called permutations. Now, let's take those same 5 kids, but instead of lining them all up against the wall, I'm only going to line 2 of them up against the wall, all right? And I'm going to order them. So same 5 kids, but let's say this time I'm going to elect from the 5 kids a pres and a vice president, all right? Now, think about this for just a second. This is pretty fun. Excuse me. What I do is I take the kids, all 5 of them, and I order them. All right? However, if you think about it, if I'm going to order only 2 of them, then what I need to do is divide out the ordering of the other students. So the 3 that didn't get elected as pres and vice president, their order doesn't matter. They're just hanging out, not doing anything. So what I do is I divide out their ordering. All right? Now, there's a notation for permutation. And what it is it's n, let's do this, it's NPR, and not National Public Radio. And the formula for this is real simple. It's n factorial over n minus r factorial. So as you can tell, what I did is in the president vice president problem, what I did is I took 5 students and I ordered 2 from within. In other words, I took 2 kids and I ordered them as president and vice president. Well, according to the formula, that's 5 factorial over 5 minus 2 factorial, which is 5 factorial over 3 factorial. Now, you could do this by hand if you absolutely had to. By the way, this is 20. But I'll show you how to do it on your calculator. But if you had to, I mean, think about it. This is 5 times 4 times 3 times 2 times 1, which is 3 factorial, divided by 3 factorial. So long. Farewell. a fetus and a 2, and we get 20. Okay? Now that's permutations. Permutations always imply order, rank, elect. You getting the point? If you are ordering, ranking, electing the things, the subset that is coming out of the whole set, then you're doing what's called a permutation, or you're permuting. The other way is combination. Now let's say same 5 kids, but instead of electing them as the president and vice president, I'm simply going to take them to lunch. All right, you have 5 kids, so I'm going to take 2 of you guys to lunch. Yeah, you wish. Okay, now think about this. This is actually really cool. Again, the thing to think about is, does it matter the order that the kids are selected? In other words, if I take Billy and Tommy to lunch, that is not different than if I take Tommy and Billy to lunch. Sorry, ladies, I don't mean to be gender biased. However, over here, when we have permutations, if Billy's the president and Tommy's the vice president, so if Billy is the pres and Tommy is the VP, that's different than if Tommy is the pres and Billy is the VP. So if you think about it for just a sec, remember this number was 20. If I'm simply going to take 2 people to lunch and order does not matter, think about it. Would you get less combinations than permutations, or would you get more if order doesn't matter? Because remember, Billy and Tommy is exactly the same if I don't order them as Tommy and Billy. Hopefully you thought about it and said, well, you get less, Ripley. Well, I'll show you why. Watch. So first things first, same thing. What I'm going to do is I'm going to take all 5 kids and I'm going to order them. Now, just like before, I'm going to divide out the kids that don't get to go to lunch because their order doesn't matter. So I divide out the 3 factorial. Okay? However, since the order doesn't matter on the 2 kids that go to lunch, I also divide out their ordering. So what I end up with is 5 factorial over 2 factorial, 3 factorial, and by the same sort of tomfoolery over here, hopefully you see that 2 factorial is 2, you end up with 10 ways to do that. There are 10 ways to select 2 things from a total to 5, from a total of 5 if, this is the biggie, order doesn't matter. That's really key. If you don't see that, you're going to have issues. Now, let's get a formula for it. And again, if you had to do these by hand, you could. All right. If somebody put a gun to your head in the park and said, "Do it by hand," you could do it by hand. Don't be afraid. But I'll give you the formula here, but I'm also going to show you how to do it on your calculators. Okay. So NCR, NPR is permutations, NCR is combinations. You'll see it this way. There's also another notation for doing this, which I'll show you in just a sec. And all that it is, and you can probably see this, NCR is n factorial divided by n minus r factorial. Notice that this little part is the permutations formula, right? Excuse me, times r factorial. And that's all it is. Okay? So again, if I do 5c2, then it's 5 factorial divided by 5 minus 2 factorial times 2 factorial, which is 5 factorial over 3 factorial times 2 factorial. It's pretty cool, huh? The biggest thing to consider is, what are we ordering? Now, I don't know how many of you have been taught this way of showing why permutations work out the way they do and why combinations work out the way they do, but for me it's really intuitive. It makes sense. We divide out the order of things where order doesn't matter. That always really helped me out. Well, this is the last lecture in Chapter 4. Like I said, I went through it relatively quickly because I'm assuming that most of you have seen this. If there are parts of it that throw you off or whatever, please feel free to pin me down and say, hey, can you explain this a little bit better, in case I didn't explain it well enough. All right? Enjoy, and I'll see you tomorrow.